And as the time is 6:37, I think, Marco, we can start, and the rest of participants will catch us later. So the floor is yours, Marco.
Okay, so today, guys, we are going to talk about the slicing process. We're going to talk about how we actually work within the Ultimate Cura program in order to create a functional G-code file, which hopefully will not lead to failures when your printer starts printing. So let me share the screen. I have already opened the Ultimate Cura. Can you hold on a minute. Thanos, can you please confirm that you can see the Cura slicing program? Or
yes, we can see it.
Yeah, yes, it's okay.
So this is the user interface of the Cura slicing program. Cura is the most, let's say, the best free slicer, in my opinion. There is also the Prusa slicer program, which is also great, but Cura slicer is the mostly known, and it's, for me, it's also very user-friendly. That's why I recommend it. So this is the program we're going to go through today. Maybe we will talk at the end a little bit for the Prusa slicer program, but I'm not sure if we will have the time. So let's talk about this first. So the first thing that you're going to see when you open the program is not this. The first time you open the program, you will see this window. And this window will ask you to add the printer to the program. So depending on the printer that you have, you will need to find your printer and add it to the program so that the Cura slicer will know which 3D printer you are using. In order to do that, you have two ways to do it. The first one is to add it through the network, which means that you have already connected the printer to your PC, if either through Wi-Fi or through cable. So if you refresh here, click refresh here, and you may find your printer here. Now, most of you will not do this. You won't be able maybe to have your printer connected to your PC, because the printer may be for amateurs. So most printers who are cheap don't have this functionality. So what you have to do is go to the Add Non-Network Printer and find your printer here. As you can see, there are many companies, there are many 3D printing companies here. So you may find the one your printer has, and you basically, for example, basically click on the company, and then you find your printer on the drop list here. So for me, it's the Creality 3D, and the one that I have at home is the Creality Ender 3. I will click on the Creality Ender 3 Pro just because I already have a profile with Ender 3, and you just click Add here. Now you have the machine settings. So what you have to do here is just double check the build volume of your printer. This is the X, Y, and Z build volume of your printer. Check that you have the rectangular build plate shape, heated bed, of course. This is basically your software. For me, it's the Marlin software. Most Ender printers have the Marlin software. This is the start G code and the end G code that you don't have to change anything here, and also the nozzle diameter, which is 1.75 millimeters, which is basically the diameter of most filaments. And let me open this picture right here. As you can, well, no, you can see it here. Anyway, most filaments have a diameter of 1.75. Just check that it's also your filament has this diameter, and just click next. So now Cura Slicer knows that your printer is the Creality Ender 3 Pro. You have this click. As you can see, you can have a lot of preset printers. Let's say that we have, I've changed it and I have the Ender 3, for example. Now, what should we do next? First of all, before even starting to talk about the parameters, we have to have a model here. So as you can see, this is your virtual build plate. As you can see, I can click here to see my build plate for from different perspectives. And as you may see here, it says Ender. This is the logo I also have on my build plate. And it actually simulates your build plate when you're printing your models. Of course, you can navigate with your mouse. And now what I want to do is add the model inside. So I can either click here on the archive, on the archive picture, and search it through the, so let's say I want the stop sign STL open, and there it is. Or I click delete now to delete it, and or I can just drag and drop it inside, and there it is again. So now that I have my model, I will need to adjust some settings and some parameters in order to achieve the best print possible. Now you can either use the recommended settings. So this is the window for the recommended settings, or you can click on custom and have a more custom, let's say, experience of how you want your settings to be. For those of you that start 3D printing now, I would suggest the recommended settings, of course, because you won't mess with all that stuff, because as you can see here, there is so much stuff that you will need to mess with, and you don't really want that for your first prints. But as you will see, you will want it after some prints. Now, let's go to the recommended settings. Now, what we have here is the layer height. This is how high is your layer. So you can either click 0.12, 0.16, up to 0.28. And those values here depend on your printer. So I have the Ender 3, and the Ender 3 goes for 0.0, has a 0.07 step. So if we multiply the step, we get those values. Okay, now let me also show you what the layer height is in case some of you don't know. Now, this is a picture that we can understand that on the upper pictures, we see a taller layer. And on the other pictures, we have the same design, but with half of the layer. So for example, here we have a 0.28 layer, let's say, and here we have a 0.12 layer. This is the difference between the two. What we can see is that, what's that? Okay. And what we can see here is that if, for example, we build a cube, we won't see a huge difference between the two. But if we build weird geometries like this, we understand that the bottom one is has much more detail than this one. So if you want, for example, to build miniatures or design work models with weird design, you may choose a shorter layer height. But if you want to print your model faster, you choose a taller layer height. So this is the layer height. You can choose your layer according to your print. And the other thing you need to choose is the infill. Now, the infill is the percentage of how is it called? Of the I forgot the word. Anyway, you will see it in the picture and you will understand. Hopefully I will remember the word. So here are 3 examples of infill. Now this has almost 100% infill. This has almost 70% infill, and this is less than 40% infill. As you can understand, the more percentage of infill, the more that's now I remember, the more material you have inside your print. So, for example, this is the stop sign here. If I decide to have a 10% infill and I slice it, let me get the support out. Okay, slice it. Now, if I go to the preview, I will see that here, this is how 10% infill looks inside your print. But if I go to 90%, let's say, and I slice again, this is what happens with 90% infill. Almost all your model is filled with material inside. Now, do we want that? In some cases we do, in some cases we don't. This is up to you to decide. Most of the cases we don't want those percentages. So the standard is 20%. The standard for the prints is 20% because it won't break that easily, but you also the printer doesn't have to print as much, because as you can see here, with 20% infill, we print on 2 hours and 55 minutes. But but if I change that to 90% infill, slice again, it goes up to 5 hours. So almost double the time that you would need to print the whole model. All right, and let's go back to the prepare view. And the last 2 is the support and the adhesion. Now the support, as you may understand, is the supporting material that you will need, for example, in these cases, because if you print it as it is, what is going to happen is this. So here we have the stop sign, and if we don't put supports on this area right here, that is what we will get. So instead of this, we put support here, and that's what we get at the end. So if I click now support and slice, I can go to the preview, and this is what I get. the blue part is where the support is. As you can see, the support goes up to this point here, just because it wants to create supports inside here for those points around. But the most important part is this one. As you understand, it prints the supports up to here. It goes up, 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 up. And when it comes up to here, you have, come on, you have a base to build your model on. All right, hopefully everybody understood that. What else? Well, oh, and the adhesion. Yes, the adhesion. Now, what do we refer to when we talk about adhesion in 3D printing? If I click on the adhesion, and then click on slice, what is going to happen is I'm going to see something like this on my model. So what is this? This is a way for your printer to help you keep your model stuck to the build plate. If I didn't have this, it would be very difficult for me to keep this on my build plate. Maybe this is not a good example to showcase that, but if, for example, I have this cute chameleon and I want to, it's a little bit hard for my chameleon to stand by itself, right? So what I need is supports, of course, and adhesion. And so now when I slice it, what is going to happen is that I have this beautiful base, this beautiful blue base that I can print my chameleon, as you can see. And this is all for the recommended settings. This also, you can click on the gradual infill. I wouldn't recommend it. Let me also showcase that. So the gradual infill, you can see it with a smaller infill percentage. So let's say this is 20% percentage. If I go up, it is still 20% percentage. 20% percentage. Okay, I don't know if that works. Anyway, it's 20% infill, even at the last layer of your orange infill. Now, if I change that to gradual infill and slice again, we'll see that, for example, here it's less than 20% infill, and as I go up, 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 it goes, the infill goes, becomes more and more and more and more, and it goes up to 100% infill when it goes up. Now, and sometimes you may want this, but generally I have this unclicked because at most times it just you just spend material and time for no reason. So keep that in mind. This is what gradual infill is. You may want or you may not want it. Now, these are the recommended settings. This is the Ultimaker Cura program, and I will stop for 1 minute, just in case you have any questions, guys. And then we will move on to the recommended settings. Any questions?
Feel free to ask whatever you like, or you can write it in the chat. And of course, you can always write in the chat while Marcos is talking and presenting.
Exactly. What if our printer is not on the non-network list?
Mhm.
Okay, great question. Great question, Dimitra. So, this is one of the tough questions because if your printer is not on the non-network list, you will have basically to adjust everything by yourself. So what you will need to do is actually, I think there is an option to do a custom. Yes, this one. So you click on custom printer. You click on custom FFF printer. So FFF, I don't remember what it stands for, but it's similar to FDM printer. So basically it's custom FDM printer. Maybe you put the name here. So let's say Dimitra's printer. You add your printer, and now you will have to adjust everything by yourself, everything. The build volume, the print head settings, even the start and the end G code. So obviously you can't do it by yourself. And what I would suggest is Googling it. So at most cases, if your printer is a custom printer and it is not on the list, you will need to find those settings on the manufacturer of the printer or at someone at YouTube who actually works with this printer. I can't tell you exactly what to put because each printer is different and each printer has different parameters. And of course, after that, you will need to readjust the parameters on your printer here on the walls, quality and stuff. You will need to readjust all that stuff depending on the printer that you have. Yes, so that's an answer to a really hard question, actually. Okay, but a great one, a great one. So, okay, so nobody else has a question, so I will continue. All right, so where am I? Okay, let's choose standard quality. Okay, so here we have the recommended settings as we said. Now what we need to do is slice. Okay, we have the support, we have the adhesion. We preview our print, and if everything is fine, you can preview. As you can see, I'm dragging this this point here, and I can see all the layers printing layer by layer. And I can also drag this cursor, this point here, and see all my lanes printed exactly where my nozzle actually will go. Also, what I want to tell you is that the Cura slicer knows what its line is. So the orange ones is the infill, the green one is the inner lines, and the red one is the outer lines. So the blue one are the supports, and the yellow one, what is the yellow one? No, I'm not sure what the yellow one is, to be honest. We will find out. So yeah, basically now you know what those colors are. And since you are ready, you can actually save to disk. And this is the G code, guys. So I can save it on my desktop. And let me refresh. And this is the G code file right here. So you can actually take this, put it on your USB and start printing. All right. Now, for those of you who are not happy with your recommended settings, we go to the custom settings, and this is where fun begins. So let me again drag my stop sign. Right. There it is. Now, as we said, you may change a lot of things, parameters. Here, there are some choices of how you can actually view this window. So if you, for example, you click on, no, let me show you. For example, on the quality, now we have the advanced setting. If I click expert, you may see more things here. If I click all, now the words may be more interesting. Now, for example, on advanced, you may see 5 different parameters. Expert, you may see more. So since none of us is an expert, I recommend you to use the advanced settings, because if you change something on the expert settings, for example, by mistake, I just click 5 here, and I don't see it, maybe I will ruin every print after that. So don't do it. Just use the advanced ones. You don't need actually to go furthermore. So what I'm going to do is I'm going to go through all of them, most of them, most of those windows one by one, and tell you what this is. The first one is about the quality. So the quality of your print, as we said, depends on the layer height. So what you want to change here is the layer height, but as we said, depending on the step. So the step is 0.07 of my Ender 3 printer. So I could either choose 0.7, which is allowed, but I can either choose 0.2, 0.24, 0.28, or if I want fine detail, I can choose 0.04 even, or 0.08. It depends on the print that I want to do. But remember that the smaller, the shorter the layer, the more the time you need to print. But the same the material, keep that in mind. All right. So let's say that I want a quality of 0.2. Now, also, you can also readjust the initial layer. What I do here is I always put a smaller initial layer than the original layer height. So for this example, I would choose 0.12, because this way the nozzle on your first line, which is going to be this one, let me slice it. Now, if I go to the first line that I print right here, if it's a smaller layer, my nozzle will come up closer to my print bed, very close here. So it will almost touch the print bed. This way, it helps you to build a very good base which will actually fit and stick to your build plate. And this way, it's going to actually hold the whole print in place. So keep that in mind. And let's move on to the wall thickness. Now, the wall thickness is another important part. The wall thickness is, let me show you, is how many walls you need around your infill pattern. Here we chose 2, but if I change that for 0.8 to, sorry, a bird almost went inside my office. Okay, let's forget that.
Okay, Marcos, this was something unexpected, I guess.
Yes. This happens on live streams, guys. I'm sorry. So, as I was saying, the wall line count will change from 2 to 5 if I change the wall thickness. And now if I slice again, you see that I have 5 lines here. So what do we see? We see that if I want, let me hold on a minute, because maybe this will confuse you more. I'll slice again. All right. Now, what we see here is that the more the walls around your infill, the stronger the beam of my stop is. So if I wanted, if I have, let's say I want to give this to my child or to children who are 5 or 6 years old, if I give them a toy which will have two walls, let's put one so you may understand what I'm saying. Okay, so it can't be one. Let's make it two. Can't be two. Why? Okay, my mistake. So understand, this here is very easy to be broken. It can be very easily broken by a child. But if I change that to 3, for example, this is not easily broken by a child. So keep that in mind. For me, this is the most important thing when we are talking about the strength of your print, because this doesn't apply here. It also applies just here. It also applies on the stop sign. It applies everywhere. So as you may understand, well, now you will need more time to print it, but you will have a very robust and strong print. So if you want your print to be robust and strong, you can either use a bigger wall thickness or a bigger infill percentage, as I showed you before. Now, the next thing I want to talk about, first of all, let's change that to 0.8, right? The other thing I want to talk about is the top and bottom layer. And the most important, now, if you can, the top and bottom thickness. What I wanted to talk about here is the top thickness, because the bottom thickness is not really important. The bottom thickness is basically those lines here. So as you can see, it says 4 bottom layers. So this is the first layer. The second one is also 100%. Third one, fourth one, also 100%. And now after the fourth one, that's why it says 4 here. Now after the fourth one, it starts building the infill pattern. And of course, now again, we will see 1, 2, 3, 4, and again, it goes on and on. So let me show that again. There are 4 layers on the bottom of your base. Come on. 4 layers. The infill pattern starts, and after the infill pattern, again, 4 layers on the top of the base. And if I go up till here, you will see that the same thing applies here. 1, 2, 3, 4, and then the infill starts. Again, here on the last layers, obviously it's the same. Okay, 1, 2, 3, 4, and then the infill inside. So I would strongly, on the bottom layers, it's not really important. I would suggest not less than 3 though, because if you have less than 3, your customer or the person that you will give your print will see the infill, which is not really great. But for the top layers, as you may understand, it is important, because if I put 1 layer, 0.2, for example, come on, 0.22, 0.1. Can I slice that? As you see, even Cura tells me not to do it. Why? Because this is going to be the infill, and if I print on top of this infill just a layer of plastic, as you may understand, is not going to be like the picture shown here. It's going to be much worse because we don't have the base, we don't have the actual base to print on. But if I have a 0.72 top thickness layer, what happens here is that after this infill, I print a layer, it's not perfect, but then I have another layer which prints on top of this layer, which is going to be better, and then I have another layer which is going to be even better, and then the last layer is going to be perfect. So this layer is not going to be perfect, but then goes better and better and better. So the final product will look very good. So we want, don't forget that we want more than 4 top layers and more than 3 bottom layers. Now, the last thing on the top bottom window I want to talk about is the ironing. So what is ironing? Ironing is a way to create smoother top layers. And what I mean by that is that you can see on this picture the same part, but on this occasion, we didn't use layering. And here we actually clicked here and we enabled layering, ironing, sorry, ironing. So what do you see here? We can see that it's much smoother than this top layer. How does this happen? That's a very interesting question. Well done, Marcos. That's a very good question. So what happens here is that after the last layer, let me slice it. After the last layer here, is it shown? Oh, that's amazing. Does it show it? I think it shows that it's actually ironed. Let's check that, guys. So this is the ironed preview, and if I don't enable this, yes, that's where this is not ironed, as you can see. So if you see for the last layering, I just, without enabling the iron, I just print, and that's it. Now, what happens if I enable iron and slice again? This hopefully, yes. Oh wow. Okay, I didn't even know that you can actually simulate that. So if I enable iron, I print exactly the same way, but instead of stopping here, what happens is I go through all the points, but I don't print. I just go through the last layer without printing, just by touching the model. And what happens is that my nozzle is very hot. It's more than 200 Celsius. And while it touches my top layer, it creates this beautiful smooth surface that you see here. And instead of that, you have that. And it's also simulated like this. So if you want your last layer to be smooth, and also don't forget that this happens also here, guys, at all top layers. So this is also a top layer, and you may understand that also in this layer, ironing is applied. So keep that in mind. This is a great way to make your print smoother. What else? Okay, infill. I think we talked a lot about infill. Okay, let me also tell you that except infill percentage, another interesting thing you can play with is the infill pattern. So this is easily shown here. So if I choose cubic pattern, this is what I see. This is how my printer prints the infill, but I can also change that to zigzag, for example, and slice again and have this pattern. I can also change that to cross, which is another standard pattern. No, this is not the one. I meant grid, sorry. This is the one. So basically, for example, this one, the one I just chose by mistake, the cross one, as you may understand, this is not the best infill pattern. This is actually bad because you don't support anything with this one. If it doesn't, the tensions inside are bad. So what you want is something like the grid or the qubit I had instead. So this gives, because this gives you extra strength, it gives you, and it also gives you a great base that, as we said, you print on when you print your last layers. Because if, for example, you had the cross here, what would happen was that I print this, and when I print on top of this, you may understand that on these lines here, I have nothing. So I print on top of nothing. So a big failure will happen. So be careful, either use grid, qubit, or zigzag patterns. I mostly use cubic because it's actually three-dimensional pattern and not a two-dimensional pattern. Now, I wanted to talk about two more things, and then we will talk about a little bit about the supports, okay? The one is the material, which is basically temperatures. It's not actually material. And what suggests is the printing temperature. So this is the temperature that your nozzle will have while printing. This is the temperature that your nozzle will have when you print the first layer. No, printing. Okay, so this is the same, actually. Initial printing temperature. No, it's not the same. No, it's the same. It's the same. Okay. And this is the final layer printing temperature. It doesn't really matter for me, but the initial layer temperature is pretty important. For me, what works is I mostly use 10 Celsius more on those two temperatures. So for my initial layer, I add some more Celsius. Why do I do that? I do that for the same reason that I change the initial layer height. Remember here, I changed the initial layer height. And this is the same reason I changed the initial layer temperature, because at the first layer, I want it to stick, as I said, to the print bed. So in order for the plastic to stick to the print bed, I want a higher temperature. And that's why Cura gives me, and as you can see, also the build plate temperature is more than the for the initial layer than the other layers. So that's a general truth. For the initial layer, we want more temperature in order for it to stick. But of course, as we said on the previous webinar, there are a lot of ways to also create adhesion, guys, like sprays, like glue. All this helps for the print to be stuck on the bed while your printer prints. Okay, now the speed, I don't want to talk, in my opinion, guys, don't change the speed. at least for your first 100 prints, in my opinion, you don't need to change the speed. Just see what the recommended speed is and keep that, because if you change the speed, a lot of things changes on your printer and you don't want that. Most printers have a standard speed that they print. And the last thing, no, actually not the last thing, the second last thing is traveling. So traveling is when your nozzle moves without printing. And what I want to talk about on this window is the retraction mode. And what retraction does, let me see if I can find the video. I think I can find that. There is a very good video that will help you understand what retraction is. So I'm going to find it and show it to you guys. And also, if you have any question, you may ask it on the chat. Don't be afraid. All right.
Retraction settings could be one of the most important factors in getting the best prints possible off your 3D printer, but it's also one of the more mysterious settings within your 3D printing slicer. So in this 3D Printing 101, we're going to talk all about retraction. Welcome back to 3D Printing 101 here on Maker's Muse. So what is retraction anyway? Well, first, let's look at a 3D print with retraction completely disabled and see what results we get. I put this simple design together which requires the print head.
If you didn't hear it, guys, this is without retraction. So we haven't clicked the enable retraction button on this example.
Head to travel between two columns during the print. This will help demonstrate our issue. So this is called stringing, and it's a very undesirable effect of the extruder oozing plastic out.
If you didn't hear it, this is called stringing. What stringing is when the nozzle goes from here to here and it prints, and then to here and it prints, and then this is what happens. And why this happens is because there is a small part of the material thrown away when you move from here to here. So what happens is that if you enable retraction, the filament goes back to the nozzle when you move from here to here, then it goes back down again, prints, goes up inside the nozzle, then back, and it goes back and through. Let's see.
Out as it moves between points of the print. You see, as the extruder pushes filament into the hot end, this creates pressure, and this pressure wants to equalize. So simply stopping the extruder won't actually stop plastic oozing out of the nozzle. So this can make a print look terrible, and while tweaking temperatures can help to some degrees, printing with no retraction will always leave a subpar result when printing complicated models. Okay, great Angus, but how do we stop stringing? Well, this is called retraction. Retraction actually pulls filament back up from the hot end a short amount after each print move. There's actually a bit of a myth around retraction that somehow creates a suction and sucks molten plastic back into the hot end, but that's not actually the case. All retraction is doing is relieving that pressure, so when you do a travel move, the plastic's not going to so easily ooze out. So let's turn on basic retraction.
So that's it, guys. Basically, as my friend said here, it relieves the pressure, so the pressure on your nozzle, so the material will not go through and you will not have this effect. So I would recommend enabling retraction and see what happens, guys. Now, if this creates a problem, maybe just don't enable it. But if it doesn't, that in most cases it doesn't, keep this enabled.
Marcos,
What
we
else?
have a question in the
Yes,
chat room.
okay.
Sorry, we have a question. You want to say, please?
From Katerina. Okay. If I lower the speed of my initial layer, would this help my model to stick easier to the bed? Yes. Yes. The answer is yes. That's what I said exactly. That if you print it with lower speed, it's going to be easier for your first layer to be stuck to the bed. Why this happens is basically it's basic physics. Like, think about it. If I slice, let's go to the first layer. Now, if I start printing fast, I go like that, fast, and print. Most possibly, it will not be perfect. But if I print slower, like this, okay, this is not perfect, but you understand what I mean. If I print slower, what is going to happen is that most probably I will have a perfect first layer, and then I can continue printing. And okay, okay, sorry, that's why. So Katerina, I want to say sorry because I didn't talk about that. I talked about it in a previous webinar, but since you are mentioning it, let's go to the speed. Here, as you can see, we have print speed, we have infill speed, wall speed, and all these parameters. As I said, in my opinion, there is no need to change anything. But as you can see on the initial layer speed, the recommended settings is 20 millimeters per second instead of 50, which is the maximum printing speed of your printer when it will print this model. So as Katerina said, even without touching anything, the Cura slicer knows that the recommended speed for your initial layer should be lower, just because you don't print on top of plastic. You print on top of your bit plate. Then your bit plate is not made of plastic, which means that it's difficult to stick on top of it. So what we do is we minimize the speed in order to create a finer result when it comes to your first layer. So yes, the answer is of course yes. And as you can see, also the Cura slicer confirms that. Okay. So where was I? To the build plate adhesion. All right. So we talked a lot about the build plate adhesion up until now, but we will talk a little bit more. There are three basic ways to create this build plate adhesion. One is the one that we just shown on the recommended settings, which is, if I'm not mistaken, the brim. So if I, what? Why don't I slice it? Okay, because I already have the brim. Yes, so this is the brim. As we said, this is the one way to create more stability on your model. You can also change the width of your brim. Of course, you can make, this is 8 millimeters from here to here. Now, if I make it 4 millimeters, you may see that it's half the size. Another way is the skirt. Now, what the skirt does, as you see, it's 3 lines. It creates 3 lines, 5 or 10, doesn't matter, but there's no reason to do it, is that it creates an outer line. And what this does is that it makes that, first of all, as you can see, it will first print those lines, making sure that those will stick on the bed. And what this means is that if those lines stick on the bed, then also when I start printing on the inner lines, they also are perfectly stuck on the bed. So the skirt option is actually a small test before printing. Now, the third option is the raft, and this is what most people suggest to the newbies and to people that 3D print for the first time. And the brim is this one. The raft, sorry, is this one. Now, so what happens here is I actually create a small base for my model. The first layer looks like this. The second layer looks like this. The third layer looks like this. Fourth like this. And then I start building on top of my raft. And when I finish my build, I take it off and I detach the base from the raft, and I have my print. Now, for those of you that start printing, I would actually suggest trying this method for 1 or 2 times. But from my personal experience, as you may understand, it's very hard to detach the print from the raft because it's all plastic. So when you take it out of your 3D printer, it's going to be really hard to detach it. So at most cases, what I use is the brim choice, because as you may understand, you may detach it very easily, and it also is great for the stability of your model, and you can readjust it. You can, I don't know, you can make 10 millimeters base, which is a big one. Obviously, you won't have any problems with this one. So yes, those are the basic parameters. I will stop for 1 minute again, just in case anybody has a question, and then we will move on to the supports, because the most important thing, in my opinion, for a print is to know how to use the supports. All right. No questions in the chat, so I guess I'm going to continue.
Yeah, because you can continue, I think.
Okay. All right. Let me see what I want to show you guys. What I have prepared for you. Okay. So the last window we're going to talk about is the supports. Now you can either click generate supports or don't generate supports the same way you did here on the recommended settings. But here, if you click generate supports, you can see that I have more options now. Now, let's say that I just clicked generated supports and then clicked slice. What's going to happen? I think you've already seen it. This is the preview of my model this way. Now, what do we see here? First of all, we see that my supports are printed on top of my base. Do I want that? Not really. I would prefer to not that I would prefer that I wouldn't have those supports here. Can I do something about it? Yes. One thing I can do is click on enable support floor. Now, if I slice it, what's going to happen is that the slicer will create a beautiful, what is this? This, I don't know why this happens. This is a Cura problem, obviously. Anyway, let's forget this. Let's forget that this red and green lines exist, and let's focus on the supports. Now, as you can see, the Cura starts building this this pattern here, which helps me when I start printing on top of that. It helps me stick my supports on top of it. But when I take my print out of the printer, it's going to be much easier to detach the supports from the base. So yeah, This is one way, but let's say that I actually don't want it, that's not at all, okay? Is there a way to do it? In some cases, there isn't, but you can do some interesting stuff. Since I said it, I should actually tell you now. But before telling you, I need to tell you that you can also add support roof. So this is called support floor. But when we go to the support roof, and roof by roof meaning the upper part of the support, the same thing occurs. Okay, you may see that the supports are very close to my print. So let's say I don't want this to happen because again it's hard to detach. So I also enable the support roof, and I can also see this pattern here. Now let's say that I don't want this this supports on my model. Can I do something? Yes, I can actually go to the special mode, I think, or the experimental ones. Yes. Now, the first thing I can do is enable conical supports. And I will just show you guys because this is pretty self-explanatory. What? What? Okay, hold on a minute. Hopefully we will fix that. This shouldn't have happened. Support. Okay. Yes, I first have to enable, instead of support placement on everywhere, I will need to click on the touch build plate. So if I slice now without enabling conical supports, this is what I see. What happens is I asked the Cura slicer to print supports, but I told the Cura slicer, please Cura, don't print supports on top of my base, and generally don't print supports on top of my model because I don't want my model to be ruined. But if I click enable conical supports, what Cura will understand is that, okay, you don't want them to be printed on your base, but maybe you want to create a conical structure which will go up until here and actually create this design. And this way, I have everything. I have my supports not touching the build plate and also creating a beautiful base around here. Now, another way to do it is the tree supports, which are not here. I think they are. Yes, the support structure here, instead of normal, if I click tree and then click slice, now this is interesting, is something like that. Now, I think this looks like a hand. Yes, isn't that beautiful? Like a hand touching the stop. Now, as you can see, what happens is that I asked the Cura slicer to build the supports out of the build plate, so the supports are not touching my model. And if you can see closer, even everywhere here, it doesn't touch my model. Like this is going to be easier if you see the slices. That's how it goes. It goes around and around and around. It goes up, 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 not touching my model. And here that I want supports, it starts going inside the points that I want the supports, like those ones here, 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 and generally everywhere that I want supports. Now, how does Cura decide where I need supports? This is the parameter that actually helps the program decide where to put supports. And what is this parameter? It's the angle that the printer can print the model layer by layer without supports. And since it's a little bit hard to explain it, I have a picture for that. Find the picture. There it is. So this is called overhang. So for example, for my Ender 3, if I go layer by layer for a 30 degree change or 30-degree overhang, I can continue bringing layer by layer. For a 45-degree overhang, also it's possible to print, but on this, which is a 60% overhang, obviously you may understand that it's very hard to print. So I will need supports in order for my print to go step by step and print. Now, another way to showcase that, because this is basically the most important things when it comes to support. And actually, if you don't understand that, you basically didn't understand supports. So I will try to find some more things for that. Hold on a minute. Hopefully I will find it. Now I had a very cute model. There it is. Okay, there it is. The Iron Man STL. So everybody knows Iron Man. This is the model. Let's say that this is the model that I want to print, okay? Now, if I slice it, no, let's not put supports at all. I need a little bit more time to slice, of course, because it's a bigger model. A very good way to understand if you need supports on your model is this right here. Now, if you need supports, it's going to be obvious that the green lines are shown on the layer, because let's go up here. Up here. Now, you may understand that after I print this layer and I go up, I need the other layer to touch the previous layer, and up, and it goes. Now, if there is no point, for example, here you can see the green layer. So since you can see the green material, okay, the green line. Here you can see the green line, and what this means is that it wasn't built on top of some other layer. So yeah, hopefully you understand what I'm saying. This is pretty hard to understand, but for example, here you may understand that when I print this red layer, it doesn't touch the previous red layer. That's why the green is shown. If the red was touching the previous red layer, then the green line wouldn't be shown. So in most cases, when you see the green line, you will need supports. Now, a good way to avoid that is create a smaller layer. So instead of 0.2, if I slice now and I make it 0.12, so as we said, finer detail, more time, maybe a little bit more material, basically the same material, but more time. Now what you can see is no green. Why did that happen? Because now I have more detail and the red touches the previous red. And now I don't see green. Now, yeah, maybe I see this one here, but generally it's mostly red now. So no actual supports needed. Oh yeah, this is a way to understand the overhands. Now, each printer has those values pre-adjusted, so you may actually find it on the internet. This 14, okay, sorry for that. This is the support. Yes, there it is. So you may change that depending on your printer. And of course, don't forget that since you have the profile of your printer inside Cura, Cura will know what this value should be. This was all about the supports. The basic stuff about the supports, actually. Of course, you may also change the support pattern, but generally I would suggest the zigzag pattern. It works perfectly for me. Now, in some cases, like this one, since it's a very hard to print model, maybe you will need something like a grid. So you will have more stability on your supports, but generally it works. All right. So these are the supports. Hopefully you understood. I will start for 1 minute again. I will stop for 1 minute again, and after that we will talk about a little bit the custom supports. Because in sometimes you will need custom supports because first of all, custom supports will help you reduce the printing time, reduce the material you need for your prints, and also in some cases, like the one I will show you now, the supports will be everywhere. So basically, you will print a model of supports. So you will need those custom supports sometimes, guys. Okay. Any questions? Don't think so. Okay. Everybody understood everything, it seems. All right. So I will continue to the custom supports. Let's say I want to print this beautiful Iron Man statue with a standard 0.2 quality, and I add support, enable it, normal support everywhere, and I slice. What's going to happen? May have already guessed it, but let's see the preview. There it is. This beautiful blue print is going to happen. So is this okay, in your opinion? A fine print. There's a lot of problems here. First of all, we have a lot of supports touching our build plate. Now, let's say I fix that with enable support roof. Still, I have a lot of support material everywhere on my model, which touches almost all the outer parts of my model. So when I started touching the support material, I won't have a perfect model. So yes, obviously, I will need to change that. And how do I do it? Oh, first of all, I forgot to mention that sometimes Cura makes mistakes. So sometimes you may see supports that are not actually needed. Like, I don't know, like the ones here, for example. This looks like it's more than 45 degrees, which means that I actually don't need any supports here. But as you can see, it's full of support. So in those cases, what you need to do is to manually check, as we said, where the green lines are. If you see green lines, you need to put supports there. If you don't see green lines, you are fine. You don't need to add supports. Okay, so what I will need to do is unclick the generate support. And when we come to prepare here, now I will start adding the custom supports. And how do I do this? Now I have these plugins, the custom supports and the custom support cylinder that I downloaded for the marketplace right here. So you click the marketplace, and here you can see the plugins, the materials, and the installed plugins. Let's wait a little bit for the marketplace to load. Marketplace, come on. Okay. So these are some premium plugins that's more professional. And these are the community plugins that basically the users created to make the experience of other users better. Because as we said, everything on Cura is free. So I have already installed the custom supports, as we said. What you have to do here, for me it says installed, but let's say that I go to another plugin. Let's say I go to the Cura Snap Maker. You just click install, then you restart the program, and you actually have your plugin installed. It's very easy. And also I installed the cylinder custom supports. All right, and as you can see here, these are the plugins that I have. Now, let's start from the first one. The first one, which is called custom supports, is basically what the name says. I can use either a cubic support or a cylinder support, and I can change the size of them, change the base and the size. I can have a wider base or not a wider base. So based on, as you can see, if I have the wider base click, I can change the base value. So if I put 20 millimeters base value with a size of 5 and I add a support, okay, that's what I want to happen. And I click drop to build plate. Of course, this is what's going to happen. I will have a very nice pyramid. Or if I click a cylinder, I will have a very nice cylindrical pyramid. Now, of course, you don't need why first of all, why do we do this? This is pretty obvious. We do this because we want our support to be supported, basically. We want our support to have a big base in order for your support to not drop while it builds on top of itself. Because if you don't have, for example, a wider base and you have something like size of 3, for example, here. Okay, yes, this one here, for example. Now, when you start printing this, okay, let me show it. It's pretty obvious, but why not show it? So if you have this, it starts building like this, building up here and goes up, up, up. But in the simulation, it looks fine. But if you touch this, for example, if there is a small failure, let's say on your printer, it goes fast here and it touches the support while it prints it, it may fall. it may move. So what you need to do is actually use the wider base. So this time you have the size of 5 and the base of 8 or 9. And you see that this way it's actually safe. It's obvious that it's safer to print on top of itself. Now, one way to add supports is actually clicking on them and manipulating them like a model. So I can make it bigger or smaller. No.
Marcos, if you please can
Yes.
sum this up because it's almost 8 o'clock.
Okay. Okay. So
And
let's wrap it up.
Yes, thank you.
So as I said, guys, this is the custom supports. You may play with this. Let me go fast. So what I want to do is add supports where they need to be, for example, on the hand. So I click, sorry, click, 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 and you understand what I mean by that. The great thing with this is that, and of course, here on the bottom, is that if I actually click everywhere, what will happen is that when I slice it, it's not going to be like 10 different supports. It will look like actual supports. Like this, like one support pattern. So yeah, that's a great thing. So you don't use a lot of material. Now, these are the custom supports, the first plugin, and let me go second one real fast. Delete this real fast. Okay. And yes, you can also, again, you can add the cylinder and the cube the same way you use it for your custom support for the other plugin. But with this plugin, you have some also freeform supports. Come on, let me delete those. Add this support test. So let's say that I have this part here. Some great custom supports. You can go here, click on the freeform, and for example, you have the bridge that you click on the red places and you have something like this. And you can change the bridge, you can change the dimensions of the bridge and create a very cute support that does not touch your build plate. Or you can also, instead of the bridge, you can create it as buttress, which is basically a half bridge, which is like that. You see, like this one right here. Yeah, you basically understand the concept. Again, you can change the size. You have the T support, which is like that. You have the cross support, which is basically cross, like that. And yeah, so I hoped I could show you some more things, guys, but time has passed. In reality, we need 2 to 3 webinars to cover the whole slicing thing, but obviously we don't have this time. So yeah, that was it. Hopefully, guys, you understood many things on the slicing processes, and you can now print slice by yourself.
Okay, Marcus, I think everybody really understood what you were saying. Of course, it's a matter of how much time someone will spend with the program. So if any questions come up even after this webinar, you can always email us and we will answer happily to everyone. So if, do we have any questions for now? Okay, good. Thank you very much, Marcos, for these 3 webinars. Everyone was very happy with this training. I have already put in the chat room the evaluation form, the link of the evaluation form, and the link for the third for the webinar of the test of the third webinar. I have also uploaded the script. You can also find there these links. And now we will, I think we will give the floor to Elena, and she will explain to us what are we going to do for our 3 next webinars. Is that right?
Hello. Well,
Hello.
it's actually, hi. It's actually Pau, the trainer, who's going to explain us what
okay. Okay.
The floor. Pau, whenever you're ready.
Hello, can you hear me properly?
Yes, we
good?
can hear you. Yeah, yeah.
Okay. I'm sorry, I don't have a camera. I need to set it up and it's taking a lot and I didn't get it right working. But yeah, the next webinar is gonna be about Blender. I'll teach you on how to work on that program and do some basic modeling on get started in that. And it's gonna be 2 sessions, I believe, 2 webinars, 2 hours each. And I think it's gonna be, yeah, we're gonna be teaching like from how to work on the interface in the program. So workspace, move around with the camera and move objects, just the basic stuff. And then we'll move on to a bit more advanced, basically using the tools on how to model. And then we'll try to do like a basic exercise, a bit of practice, and see if we can learn, like teach like basic 3D modeling. Yeah. Yeah, I thought also, I don't know if we're gonna have time, but probably at the end gonna tell a bit like what the use for 3D modeling. So if there's people that is not fully interested in 3D modeling, they can find a bit of like, probably they get interested into it, but just there's a lot of use to it. So yeah, that's probably we're gonna be teaching. Is it good?
Thank you, Pau. Thanks.
No problem.
Okay. Thank you very much, Paul. So Blender is very interesting, I think, for everybody. It's a very fine tool. You have asked for the test links of the first and the second webinar. I have also uploaded in the chat room. Do you need the evaluation forms too? Or is this just the test links? Okay. So I think that's it for today. Thank you all for attending. Hope to see you next week. Okay. I think we can now close this meeting.